I just didn't know if it was like the name of the thing.
No, I'm not gonna prompt the test. What's this thing that I told you to remember? Leo says grr. I'll give up. No. So you could go with Leo says grr. So loss of electrons is oxidation, gain of electrons is reduction, or oxidation is loss, reduction is gain. Now, we're going to use electrons and hydrogen interchangeably here. Because remember, a hydrogen has how many electrons?
One.
So you can call hydrogen and electron the same thing. So when I have like NAD plus, and then I put a hydrogen with it, then you say, okay, we reduced it. Okay. So understand that to make ATP, there's substrate level. This is dealing with enzymes, where it says CCC squiggle P, that means there's a 3-carbon molecule with the phosphate on it, and that's going to sit in the enzyme, and ADP is going to sit in the enzyme, and the enzyme is going to yank off that P, the squiggle P, and put it with ADP to make ATP. So that's all happening in an enzyme. And then there's oxidative, which is the electron transport chain, which is redox reactions. And then what plants do is called photophosphorylation, where light, photo, must hit the chlorophyll to excite electrons. So now the movement of those electrons would be the making and breaking of bonds, because it's electrons that make and break bonds. I don't need you to know the numbers, but I do need you to understand ATP is minimal in glycolysis, ATP production is minimal in Krebs, and it's abundant in the ETC. So I don't need to know like 30 how much. I'm not going to do 32, 34, 38. I'm not going to do that. Here, what you need to understand, you're going to start with glucose. Okay? You're going to input ATP. ATP is going to break off of P and put it on either end of glucose. Okay? So you're going to have you're going to have glucose, and one ATP comes in, gives a P, another ATP comes in, puts another P, then you have to chop it in half. So instead of having poo, it's going to be poo and oop. Okay? So the poo part is going to be DHAP. And the oop part is going to be GP. And DHAP is the part that's not stable. So you change into one that's stable, which is GP, and you go from there to make pyruvic acid. That would be the end of glycolysis, but really it's an intermediate because you can't do anything with pyruvic acid. You can either go to the Krebs cycle, in which you have to change pyruvic acid, or you're going to have to do fermentation, in which pyruvic acid is going to have to do lactic acid fermentation or alcohol fermentation. Or there are alternatives to glycolysis. At the end of the day, you are going to be breaking down some kind of sugar. The pentose phosphate pathway will break down a 5-carbon sugar, whereas glucose is 6-carbon. So there are different sugars out there like lactose, sucrose, fructose, glucose, dextrose. There's acid alcohols like mannitol, sorbitol. So you can break down all of those. So pentose phosphate pathway is going to break down pentose. Then there's the etner-deuteroff, and you're going to make ATP. You're going to make electron carriers, but you're not going to do glycolysis. Like the first one's glycolysis, but using a 5-carbon sugar. The second one isn't. So how could I word this? The alternative to glycolysis using a pentose would be with which route or which pathway, and make the first one.
Do we need to know for the regular glycolysis is called the embedding layer door method?
No.
Okay, you're not gonna.
That's just who invented it, or not, or who discovered it. Okay, so you wanna go to the Krebs cycle, cause you're aerobic. Change pyruvic acid in the cytoplasm. Pyruvic acid's not gonna go into the mitochondrial matrix. So you must change it in the cytoplasm. Really? Okay, so pyruvic acid, you're gonna put in a CoA, and it'll become acetyl-CoA. You're gonna lose a carbon in the form of carbon dioxide. Every time you lose carbon, it'll be in the form of carbon dioxide. It's not gonna be like a carbon floating around. So essentially the acetyl part is gonna join with oxaloacetic acid to make citric acid. And you're gonna do your cycle. The part that you're gonna make ATP though is gonna be the succinyl step, the succinyl-CoA. Could you see that little squiggle there? High energy bond, that means ATP is coming along. The important thing here is to know that the Krebs cycle is going to generate carbon dioxide and electron carriers. Reduce electron carriers, because like NAD is going to come in and pick up an H. FAD is going to come in and pick up two H's. So you're reducing these. Okay. So all those reduced carriers now, they need to go to the electron transport chain. So they're reduced, so they have hydrogen, meaning they have these electrons. They're gonna give up their electrons. And electrons are gonna flow. At the same time, you're gonna have chemiosmosis where hydrogen is pumped out of the mitochondrial membrane. You must have a membrane here to do this process. Isn't osmosis the movement of water through a membrane? So chemiosmosis will be the movement of hydrogen through the membrane. We do this in our mitochondrial, the inner membrane, whereas prokaryotes, the only membrane they have is their plasma membrane. So they'll do it there, we'll do it in the mitochondria. Hydrogen is being pumped out as the electrons are flowing. Hydrogen accumulates outside the membrane. That's not what hydrogen wants to do. It doesn't want to accumulate. It doesn't want to be crowded, right? So hydrogen's going to flow back in through a protein, an embedded protein called ATP synthase. ATP synthase will spin like a turbine and crank out ATP. So if we're aerobic, oxygen will be the last little guy at the end that's going to get the electrons. If you're not aerobic, you'll be something else. So it could be like nitrate, sulfate, carbonate, anything else. Okay, fermentation, as I said, you're going to go either like the lactic acid fermentation or the alcohol fermentation. Let's say I gave you an example on a test and said lactobacillus would employ what kind of fermentation? Lactic, it's in the name. If I said Saccharomyces cerevisiae, alcohol, because what's Spanish for alcohol? So there we go. Spanish for beer? There we go. So that she doesn't dead giveaway. Okay, all right. So fermentation test, which you will eventually get to do in the lab. A is the control. In this tube, we're going to have